Alright, so this is going to be the solution to the 13th problem in the grind 75. This one is called linked list cycle. We are going to go over the problem description really quick. I'm just going to delete some notes from the, or some previous implementation from the attempt. So let's go over the problem description. So we're given the head of the linked list, and we want to determine if it has a cycle. They also tell us about something called a position, POS, which is the physical position in the linked list. Our input is an array, or in this example, it's represented as an array, so we can obviously see the position in it. And the position, specifically for linked lists with cycles, is the point at which the very last one loops back to a node we've already seen before. And something it actually says at the end, which actually is a hint, which makes it even easier to solve, is can you solve it using constant memory? And my initial thought was to use a fast and a slow pointer, where the slow pointer would move one at a time and the fast pointer would move two at a time, and eventually they would overlap. But then we were hit with a test case that had a linked list of all ones and no cycles. But the thing is, I was comparing fast and slow values. The values that were found at the nodes that the fast and slow pointers were pointing to. And I guess I could have also just used the physical list node object, but there's an even simpler way of doing it that doesn't require us to terminate at the right spot and have extra pointers. So what I came up with was to create a hash set. Let's actually, yeah. So a hash set, all we're going to have in it is list nodes, and we're just going to call it visited nodes. And that is going to be equal to an empty hash set right now. List node. And we don't need to come up with any extra pointers. We can just say, while the head is not null, we are going to check if we have already visited the node that head is currently pointing to. If that's the case, then that means we have a cycle on our hands, and so we can return true. Return true if there is a cycle. Otherwise, we are going to add head to our hash set by doing visited nodes.add head. Something nice about hash set and hash map is that they have similar methods, so I'll remember that in Java specifically. So they have an add, they have a contains, they have a remove, is empty, so forth. And then we just need to move our pointer on. And if we've gotten to the very end where head is equal to null, then we know that we haven't found a cycle, and we can just return false. And this is the solution. Let me run this test case first to make sure we didn't have any syntactical errors. But first I have to wait for the Wi-Fi to come on. Okay, going to run the test case. Wi-Fi disconnected again. I will pause and move a little closer to the router. All right, let's run the test case before the Wi-Fi goes out. And okay, let's see, what did we do wrong here? Better do that, add those parentheses. Okay, no syntactical errors. All right, so that is the solution to the 13th problem in the grind 75. This has been linked list cycle.